In section 2, we are going to look at the first of 4 of our conic shapes, and specifically we're going to focus on graphing. We're going to do a couple things today. First, we're just going to talk about general graphing from vertex form. Then secondly, we're going to talk about converting from a standard form of an equation into vertex form. And then finally, we're going to review using the axis of symmetry, vertex, and y-intercepts to graph a parabola. So let's look at our first process. This is going to be very familiar with what we've done in the past. We're going to focus on graphing using vertex form here. And our vertex form, as you can see here over on the right-hand side in blue, is y equals a times x minus h squared plus k. Now, the a has to do with the shape of the parabola. The higher the number a is, the skinnier the parabola is, and the closer the number a is to 0, the wider the parabola is. H and k are the locations of the vertex. Notice it's the opposite of the middle number, and k is the actual number. So just a very quick example here. If we had y equals x minus 3 squared plus 4, the vertex would be 3, 4. If we had the equation y equals x plus 2 squared plus 1, the vertex would be negative 2, 1. All right, so let's just kind of graph these very quickly. So we're going to start here on each problem by identifying the vertex. The vertex is 3, negative 2. So we're going to go to 3, negative 2. Now, from this point, we can use the pattern of a parabola, which is 1, 1, 2, 4, 3, 9. Now, I did put the values here, 1a, 4a, and 9a, because if there's a number in front of the parentheses being squared, then we're going to multiply that 1, 4, 9 by that number. Here, our number in front of our parentheses is 1. Okay, so we do not really have any multiplier. So our pattern from this vertex is going to be over 1, up 1. Go back to the vertex, over 2, up 4. Go back to the vertex, over 3, up 9. Two, 3, 4, 5, 6. Okay, and there we have a very short, simple way to graph our parabola. Let's look at our example 2. Here we have a vertex of negative 1, 4. It's always going to be the opposite of this interior number, but the a value here is negative 1. What does that mean? That means our parabola is going to be upside down. So let's go to negative 1, 4. There's our vertex. Our multiplier is negative 1, so over 1, instead of up 1, we're going to over 1 and down 1. Notice for the symmetry here, over 2, down 4. The symmetry there, over 3, down 9. 1, 2, 3, 4, an additional 5. Now, I hope you can imagine what the next points would be. Over 4, down 16. So it just continues with a pattern of perfect squares. All right, example 3. I chose this one individually and specifically because there is no h value. If you wanted to write this in vertex form, it would be very simple to do so. 2 parentheses x minus 0 squared minus 4. And the reason I write it that way is for you to identify that the vertex is 0, negative 4, and the multiplier is 2. So we're going to go to 0, negative 4, put our dot. A value is positive, so that means it goes up. So instead of going over 1, up 1, we're going to go up the value of a over 1, up 2. Normal next step would be 2, 4. Now it's going to be 2, 8. So over 2, up 8. 2, 4, 6. Sorry, 2, 4, 6, 8. Instead of over 3, up 9, it would be over 3, up 18. But that is off the graph. And so we have our graph right here as we're sketching this. Now, just comparing these to the first two, you'll notice that this graph is skinnier, and that is because the value of a is further away from 0. All right, example 4. We've got negative x squared plus 3. Once again, we can write that in vertex form of negative x minus 0 squared plus 3. That means the vertex is 0, 3, and the a value is negative 1. So we can go to 0, 3. Our a value is negative 1, so over 1, down 1, over 1, down 1, over 2, down 4, whoops, excuse me, and then over 3, down 9, 3, 6, 9, and then reflexive over to this side. And there we go. Very quick in terms of vertex forms. Once you have it in vertex form, the graph really shouldn't take you much longer than it takes to count the points and do your pattern of 1, 1, 2, 4, 3, 9. Okay, let's look at our second idea. Next, we're going to take something that's not in vertex form, that's in standard form, and we're going to convert it into that ax minus h squared plus k. So to do this, I've got some steps to follow. We're going to move the constant over to the other side. So on this first one, it would be 2 or 5 or 7. We're going to factor out the a coefficient from the x squared term. Then we're going to take half of this middle term, 6, square it, and add it to both sides of the equation. If there's an a value like there is on number 6 or number 7, we're going to multiply that other side of the equation by that number, so we balance the equations. We're going to rewrite it then, that perfect square trinomial, as a binomial squared, as that x minus h, and then we're going to bring the constant back over to write it in vertex form as we finish. So here we go. First of all, on this first one, I am going to move the 2 over to the other side by subtracting 2. Next, I'm going to have to add the same thing to both sides to make this 6x into a perfect square trinomial. Half of 6 is 3, 3 squared is 9, so I'm going to add 9 to both sides. That gives me y plus 7 on the left, and it gives me x minus 3 squared on the right. There's my binomial squared. So I bring the 7 back over, x plus 3 squared minus 7, my vertex, negative 3, negative 7, my a value is 1. So we can come down to our graph at the bottom. We can go to negative 3, negative 7, and from that point we're going to do our pattern 1, 1, 2, 4, 3, 9. This is a rare occasion where we might be able to go 4, 16. 1, 2, 3, 4. That's 7, 8, 9, 10, 11, 12, 13, 14, 15. So even this one is actually off the graph. So it's very difficult to get that 416 on the pattern on the graph itself. But there we have converting from standard form into vertex form. Let's look at example 6. First off, just like before, we're going to move the 5 over to the other side. We have negative x squared minus 2x. Now, new step here, we're going to factor out that negative 1. So negative 1 parentheses x squared plus 2x, because the x squared needs to be positive. Now we're going to add in the blanks to both sides. So plus blank equals negative 1 x squared plus 2x plus blank. Now I'd like you to think with me, half of 2 is 1, 1 squared is 1. Now in this case, we're not really adding 1. We're really adding negative 1 times 1. So I'm going to put a minus 1 over on the left side of the equation. New result, y minus 6 equals negative 1 times x plus 1 squared. We bring the 6 back over. The a value is negative 1, x plus 1 squared plus 6. So my vertex, negative 1, positive 6. My a value is negative 1, so this parabola is going down as we start. So let's take a look at how this is going to graph. Negative 1, 6, over 1, down 1, over 2, down 4, over 3, down 9. And there we have our sketch very quickly. The goal here is this is not going to take you very long to convert these. The most important thing to pay attention to this one is factoring out that negative 1 and then multiplying the negative 1 times the 1, so that equates to a balanced equation on the other side. All right, let's do another one similar to this where we have a multiplier of an a value. We're going to bring over the 7, used to that by now, 2x squared minus 8x. We're going to factor out that 2, x squared minus 4x, and now we're going to add a blank to both sides of the equation. X squared minus 4x plus blank. Half of 4 is 2. 2 squared is 4, but we're really not adding 4. We're really adding 2 times 4. So we're really going to be adding 8 to both sides. We rewrite the equation. Y plus 1 equals 2 parentheses x minus 2 squared, because it's half of this middle term. We bring the 1 over, x minus 2 squared minus 1. From here, the vertex is 2, negative 1. The a value is 2, so be prepared for a little bit skinnier graph, but it is going to be going up. Let's take a look at what this looks like. We go to 2, negative 1. Our normal pattern is 1, 1. Now because the a value is 2, it's over 1 up 2. Instead of going over 2 up 4, we go over 2 up 8. So 2, 4, 6, 8. And just like that, we are off the graph. We do not even have the ability to do the 3, 9 point. Okay, so there's 3 examples of changing from standard form into vertex form. Very straightforward. We're just going to need to make sure that we show our steps for each of these, and you have that ability to convert. That's how you get from standard form to vertex form. All right. Now let's move to our last part, where we're using that same standard form, except we're using a different method and talking through the ideas of axis of symmetry, vertex, and the y-intercept to graph. So on these, our problems are going to need to start by being equal to 0, and we're going to have to identify the values of a, b, and c. So a is 1, b here is negative 2, and c is 8. So I'm going to put that in a box on the left, and now I'm going to find my axis of symmetry. My axis of symmetry is the value, the opposite of b over 2a. So the opposite of negative 2 over 2 times 1. So in this case, that's 2 over 2, or x equals 1. So my axis of symmetry is x equals 1. So I'm going to graph that down here as a dotted vertical line, x equals 1. And I have to know that my vertex falls on that point. So I'm going to take my value, x equals 1, and I'm going to plug it in to my vertex. Now I need to find the value of y. So we go back to our original equation. We plug in 1, so 1 squared minus 2 times 1 plus 8. Now some people say, why did you plug in 1? Because that was my axis of symmetry. So y equals 1 minus 2 plus 8. So 1 minus 2 is negative 1, so y equals 7. So my vertex is at 1, 7. So there we have it. And we're going from there. From there, we have to identify what our y-intercept is. Remember, our y-intercept is the value 0, c. c is the value 8. So 0, 8. And there we go. Now, what's neat about this is the ability to check. Even though we're way at the top of the graph here, as we graph this, if we go from the vertex and we go over 1, up 1, we get on the axis. We get from the axis of symmetry to the y-intercept. That's our check, to make sure that our vertex form arrives back in comparison to the axis of symmetry. Okay, let's look at example 9. I've intentionally put a negative sign in here. I hope you realize by now that means the graph is going to go upside down. So a equals negative 1, b equals 4, c equals negative 3. My axis of symmetry, the opposite of b, so negative 4 over 2 times negative 1. So negative 4 over negative 2 is x equals 2. So I'm going to come down to the bottom. I'm going to graph the value x equals 2. That is my axis of symmetry. I'm going to plug that value back into my problem and find out my value. So y equals the opposite of 2 squared plus 4 times 2 minus 3. Be careful here, this is a negative 4 plus 8 minus 3. So y equals positive 1. So my vertex is 2, 1. Put this in a different color so it's easier to see. So there's my vertex in blue. Now my y-intercept, I'm going to come back to my problem. Remember that 0c. So 0, negative 3. This is 2 points away from the dotted line, so we go 2 points on the other side. And then we can just think about, does this match up with our pattern? The A value is 1, so we're going to fill in our patterns from what we know. Over 1, down 1, over 1, down 1, over 2, down 4. I need you to notice that that 2 and that 4 match up with our vertex y-intercept point. That's a great check, and that means that you've done this correctly, and it's a great way to check our problem. All right, let's look at our last one. Our last one, we have values of 2, -12, and 6. So A equals 2, B equals -12, C equals 6. Our axis of symmetry, x equals the opposite of -12 over 2a, 2 times 2, so 12 over 4, or x equals 3. So I'm going to come down here, we're going to graph x equals 3. Remember, when you're putting down an axis of symmetry, just as a reminder, it's an equation. It needs to have an x equals, and I know that seems trivial, but we've really worked hard to make sure that we're doing that. Okay, let's move on from here. Let's find the vertex. 3 comma blank, 2 times 3 squared minus 12 times 3 plus 6. So that's 2 times 9, or 18, minus 36 plus 6. That's -18 plus 6. That's -12. So that comes back up here. 3 comma -12. It's a good thing we have some extra space at the bottom of our graph. Over 3, this is 8. So 9, 10, 11, 12. We then go to our next point, which is our y-intercept. Our y-intercept is going to be the point 0, comma 6. So that's way up here. And so we're really going to have to make sure that we're on the right path. Remember, we're down here at 3, -12 because of this extreme situation where we had a value of 3 for our axis of symmetry, and going from there. So let's do our pattern to see if this actually works out. Remember, we're down here at -12. Okay, so over 1 up 1 takes us to -11. Over 2 up 4 takes us to -8. Excuse me, we just made a mistake. I forgot to mention our A value is 2. So we have a multiplier going in here. So instead of going over 1 up 1, I go over 1 up 2 to -10. Instead of going over 2 up 4, I go over 2 up 8. So that's 4, 5, 6, 7, 8. And instead of going over 3 up 9, I go over 3 up 18. Well, this is 12, 13, 14, 15, 16, 17, 18. And so we did match up with our points, and they do match our normal process. You'll notice once again that this graph is much, much narrower than our other graphs that we have, and that's because of the value 2. So we've got a different method here using y-intercept, axis of symmetry, and the vertex to graph our problems using that same pattern as we did. In the middle page, we talked about transmitting to vertex form and what that looks like. And then on our first page, just using vertex form to graph our equations. So graphing parabolas, our first major form of conics as we're working through this. Our homework tonight will be a worksheet that will work through graphing these same ideas.